Okay, I am going to continue to go through the odd problems on the homework 1. Last video we worked through problem 1 together. Next we're going to take a look at number 3. So number 3 says given parallelogram ABCD, solve for x if, and they give us some values for AD, AB, BC, and DC. And so if we look at where those are on this diagram, you know, AD is this length here, so it's one of the sides, and actually we're given information on all 4 sides. So this is information regarding the sides of this parallelogram. And so we want to know, are there any properties about the sides of a parallelogram? And this is why I said you want to have all these properties memorized, and in particular for a parallelogram in regarding to its sides, there's only one property, and that's that opposite sides are congruent. And so we're going to apply that here. I'm going to write opposite sides are congruent. And if opposite sides are congruent, that means their lengths are equal. So the length of AD is going to equal the length that's opposite of it. So AD and BC are going to be equal. Or I could also say that the length AB is equal to the length DC. And we're given values for all 4 of them. We only need to solve for x, so we only need one of those relationships. And it doesn't matter, you can go with AD equal to BC and set that up, or you can go with AB equal to DC and set that up. They should both lead to the same solution. I'm going to go with the first. So AD is 10x squared plus 30x plus 4. And that's equal to BC, which is 2x squared plus 2x plus 4. So I set them equal to each other. And if you forget how to solve equations, I gave you that solve by factoring handout, right? And on all of them, remember step 1 says to make your equation equal to 0. And so that's what I'm going to do here. So I'm going to subtract 2x squared from both sides. I'm going to subtract 2x from both sides. I'm going to subtract 4 from both sides. And so the right side gets zeroed out. And we're left with 8x squared plus 28x is equal to 0. So that's your first step. Make it equal to 0. Then from there, the second step is to factor. And you have to, there's 5 different types of factoring, and you have to decide which type applies to this one. To help you decide that, you look at how many terms you have, and with 2 terms, your choices are the GCF factoring, which is what you always want to try first, and it's going to actually work in this. So GCF factoring is the key one. And if you want to see an example like that, it would be your type 3. So I factor out a 2 and an x. Actually, I could do even better than that. I could probably factor out a 4 and an x. And I'm left with 2x plus 7. And then once you're done factoring, you split up your factors, so 4x is one of my factors, and set that equal to 0, and 2x plus 7, set that equal to 0, and then you solve each one for x. So I divide by 4 here, and I get x is equal to 0. I'm running out of space here, so x is 0 is one of my answers. And then here I'm going to subtract 7 from both sides and get 2x equals negative 7. I'm going to move that over here. And then I'm going to divide both sides by 2 and get x is equal to negative 7 over 2. And so we have two answers, x equals 0 and x equals negative 7 over 2. Moving on to number 5. 5, the shape changes, and it's telling us we have a rhombus. You want to remember the definition of a rhombus is that all 4 sides are the same length, AB, BC, CD, and DA. And we're asked to solve for x if measure of angle 1 is 20 degrees, and the measure of angle 8 is 5x squared minus 17x plus 84. And so the information given to us is measure of angle 1 and the measure of angle 8. And so we're trying to find a relationship between those angles, because if we can, then we can set up an equation. Until we can't set up an equation. And so we need to do a little bit of thinking here. And it's going to come down to us knowing our properties of a rhombus. And it's got to deal with some kind of angle property. So if I go back to our diagram and think about that. So a rhombus, we know the diagonals are perpendicular, and that deals with angle measurements, right? We have, here we are, if I look at diagonals being perpendicular, okay, that means our diagonals form 90 degrees. And so if I went back to our homework, that means that angle 9, angle 10, angle 11, and AEB would be 90 degrees. So that's nice to know. And that's actually enough for us. Because if angle 9, so the measure of angle 9 is 90 degrees, and we're told that the measure of angle 1 is 20 degrees, then we can figure out what the measure of angle 8 is, because all 3 angles added up together is going to add up to 180. And so I'm going to, let's just say I need to solve for x, so I'm going to make up a new variable. I'm going to call it y, and just figure out what angle 8 should be. So y plus 20 plus 90, those are the 3 angles inside of that triangle, ADE. We know that the 3 angles inside of any triangle have to add up to 180. So y plus 110, I just add the 20 and 90, it's going to be 180. And then if I subtract 110 from both sides of the equation, I get y is 70 degrees. And which means that the measure of angle 8, that's what I was trying to figure out, is 70 degrees. Okay. So our problem here, it tells us that the measure of angle 8 is 5x squared minus 17x plus 84. And we found that the measure of angle 8 is 70. So I'm going to put that equal to 70, right? Because both of these are the measure of angle 8. So we just found two different representations for the same value. One was the equation given to us, and then the other one we solved for that third angle in the triangle, and now we're setting them equal to each other. So that's the relationship we need to even get started here. And by the way, I need to write what property we were using. So the property that, there's actually two things that unlock this problem for us. First of all, we used the property that the diagonals of a rhombus are perpendicular. And then second, we use the fact that all three angles inside of a triangle add up to 180. And together they helped us set up our equation. So now we need to solve for x. First step is to set this equal to 0, so I subtract 70 from both sides and I get 5x squared minus 17x, and if I subtract 70 from 84 I end up with 14 is equal to 0. And then I need to decide how to go ahead and solve this. And this is the type of problem that we're going to use the trinomial factoring. And why do I know that? Well, because I have three terms. And if you want a reference of something that would be like that, if you look at type 5, the example there, this is what we're going to be doing to solve this problem. So I'm going to think about how to split up my middle term, the negative 17x, into two terms that add up to it. So I want the sum of the two terms I come up to be negative 17x. And at the top here I'm going to multiply the 5 and the 14. So I'm going to go 5 times 14 x squared, and 5 times 14 is 70, right? And so I'm looking for two terms that multiply to 70 and add to negative 17. And negative 10x times negative 7x will multiply to positive 70x squared and add to negative 17x. So that's what I'm going to replace the negative 17x with. So in my problem I have 5x squared. Instead of negative 17x I put negative 10x and the negative 7x plus 14 is equal to 0. So I've transitioned from 3 terms to 4 terms, and then I factor it by grouping. So I look at the first half, factor out the GCF, which is 5x, and what's remaining is x minus 2, and then the sign in front of the third term is a minus sign, so I put a minus sign there, and I look at the 7x and 14. The GCF is 7, so I'm factoring out a negative 7, or dividing each of those by negative 7, and I get a positive x minus 2 again. Then I look at the 5x times x minus 2 is one term, and the 7 times x minus 2 is the second term, and they both have a common factor of x minus 2. I factor that x minus 2 out, and I'm left with a 5x from the first term and a 7 from the second term. And that's the way factoring a trinomial works. So now the trinomial is factored, and I separate my factors and set them individually equal to 0. And solve. So the first one I get x is equal to 2. The second one I get 5x is equal to positive 7, so x is equal to 7 divided by 5, or 7 over 5. Alright, our next problem we're going to look at is number 7. Again, we're working with a rhombus, ABCD, and we're going to solve for x if they give us AB and BC. So I'm going to locate AB's here and BC is right here. So those are two sides that we're given, and we want to know the relationship between those two sides. Well, the definition of a rhombus tells us that all four sides are the same length. So if you know the definition of the rhombus, then you know that the length from A to B is equal to the length from B to C. So here, what property are we using in order to write our equation? We're actually using a definition. So it's not a property, but that's okay. And we're just using the definition of a rhombus. Which states that all sides are congruent. And so from that we can set up our equation, 4x squared plus 3x minus 25, that's our AB, and that's going to be equal to BC, which is x squared plus 10x plus 15. And when we solve, our first step is to make one side equal to 0. So I'm going to subtract x squared from both sides to 0 out that part. I'm going to subtract 10x from both sides to 0 out the middle term, and subtract 15 from both sides so that the whole right side gets zeroed out, and I end up with 3x squared minus 7x minus 40 is equal to 0. And I'm noticing I have three terms here, so this is the trinomial factoring again. And if you want to reference that from the solving by factoring page, that's your type 5 that you can look at and follow those steps there. And so we're going to need to split up that negative 7x, that middle term, so that the sum of the two terms we come up with will add up to negative 7x. And our product of those two terms is going to be whatever 3x squared times negative 40 is, which is negative 120x squared. So I am going to be thinking through this a little bit, because it's not an obvious one, right? We're going to think, well, what times what is 120? And to do that, I'm going to factor 120 down to its prime factors. So 120 is 2 times 60, and that's 2 times 30, that's 2 times 15, and 3 times 5. So 120 is made up of the primes 2 times 2 times 2 times 3 times 5. And so any two numbers that multiply to 120 will contain these primes. And I can create different numbers using these primes. So for example, I can take the three threes, and that would be 8. And what remains is the 3 times 5, which would be 15. And I know that 8 times 15 would be 120. And it just turns out here that that's exactly what I need, because if I subtract 8 and 15, I get negative 7. So I'm going to have a 15x and a negative 8x, because here this is going to work for me. When I add those together, I get negative 7x, and when I multiply them together, I get negative 120x squared. So I rewrite this as 3x squared plus 15x minus 8x minus 40 is equal to 0. So I split the negative 7x, I replace that with the two terms that we worked to find, right? And now I'm going to factor by grouping. So the first two terms I could factor out of 3x. What remains is an x plus 5 minus, I can factor out an 8. And what remains is an x plus 5 again. And I'm getting plus 5 because I'm dividing the negative 40 by the negative 8. That gives me the plus 5. And then both of these terms that I'm underlining have a common factor of x plus 5. And so I factor out x plus 5. And what remains from the first term is 3x. What remains from the second term is the 8. And now I'm completely factored. And I set each factor equal to 0. And solve, and I'm going to get two possible answers for x. So x equals negative 5 is one of my answers. And here I add 8 to both sides and then divide by 3, and I get x is 8 divided by 3, or 8 over 3, for my second answer. Let's go now and take a look at number 9. Number 9, we're told that this shape is a rectangle. And remember, a rectangle's definition means all 4 angles are congruent, if we were to take out those diagonals, right? And we're given a couple things. We're given angle 5 and we're given angle 4. And so let's look at where those are. Angle 4 is right here, angle 5 right here. And we're hoping to find a relationship between those two angles. And we're going to have to think a little bit about a rectangle before we can come up with that relationship. So let's go back and think about, what do we know about a rectangle? And it seems like it's regarding angles, right? And so let's go think about what we know about rectangles. So first of all, the definition of a rectangle is all the angles are congruent. So if I go back here, and because all the angles in a rectangle are congruent, and because a quadrilateral, all 4 angles add up to 360, we know that all 4 of these angles are 90 degrees. Okay, so that's one thing we know. And so, like, for example, if I gave you angle 6 and angle 5, that makes up a corner. So we know that angle 6 and angle 5 add up to 90. But angle 5 and 4, I'm not sure. It looks like it's cut in half, like angle 5 is 45 degrees. But don't go by the appearance. You have to rely on properties. And in fact, we're going to find that that angle is not cut in half, because that's not a property of a rectangle. So let's keep thinking about it. Diagonals are congruent. That doesn't deal with angles. So let's just look at the angle part. We'll come back to the other types of properties. And so that's the only property that's specific to a rectangle. But remember, a rectangle is also a parallelogram, so all the properties of a parallelogram apply to this as well. So consecutive angles are supplementary. Let's think about that one. So in our picture here, supplementary angles are, well, we already know that because two angles next to each other, the ones I'm circling, are going to add up to 180 is what it says. Well, yeah, we know that because these are all 90, so that's obvious to us. Opposite angles are congruent. Well, that's another obvious thing to us because all the angles are 90 degrees, so yes, opposite angles are congruent. So none of these are seeming to help. We're just thinking through this. And that's all we have on angles. So the angle properties are not helping us with finding a relationship between angle 5 and angle 4. So we're going to have to now dig a little deeper here, and I'm going to lead you to what's going on here. So there's two properties that we're going to grab. We're going to need, I'll mark it here, we're going to need that the diagonals are congruent, and then we're also going to have to mesh that together with the diagonals bisect each other. Okay, and if you put those two properties together, you get something special with a rectangle, and that's what we're going to work out here. So if the diagonals bisect each other, so what that means is that they cut each other in half. So this length here matches this length here, right? And then this length here is going to match this length here. And so I'm going to write that down. So our first property, we're going to use that diagonals bisect each other. And keep in mind that this property comes from parallelograms, not from rectangles specifically, but because a rectangle is a parallelogram, it applies to this case. And then the other thing is, well, those diagonals are congruent. So let's say the two diagonals were length 10, whatever the units are, right? If these are both length 10 and they're both cut in half, then that means these two would be 5 and then these two would be 5. So that means all four pieces that we get when we cut our diagonals in half are going to be the same length. And it doesn't matter, I just made up 10. You could pick any length. But if the lengths are the same, then what happens here is really all four of these pieces are the same length. And that's a unique property there in and of itself. We didn't spell that out, but it's something you want to know with rectangles. And it only works with rectangles, that all four of those smaller pieces are going to be congruent. Now if we put that together here, that means that CE and BE are congruent, and we get this isosceles triangle. And so then the isosceles triangle theorem says that our base angles will be congruent. So now we can say that the measure of angle 5 is equal to the measure of angle 4. And because we have that isosceles triangle, and I'll just write isosceles triangle theorem here. So although we're not doing proofs, we still need to remember some of the things that we did when we were proving. And so now we finally found our relationship. And so coming up with the equation is not always a quick, easy thing. You have to do some thinking about how they are related to each other, and make sure you're confident on that. So that's why, again, we want to know these properties. We want to know how these things work inside and out. So now I'm going to set 4x to the third plus 8x squared equal to x plus 2. And then our first step for solving is always make your equation equal to 0. So I'm going to subtract x and subtract 2 from both sides. But I notice that I don't have any like terms on the left side, so I'm just going to be rewriting them, and I'll be like this: 4x to the third plus 8x squared minus x minus 2 is equal to 0. And notice we have 4 terms equal to 0, and so we're going to be using the factoring by grouping, which is something you use when you have 4 terms. And if you want to refer to one of these types that I gave you, the factoring by grouping is outlined in type 4. So when you factor by grouping, you look at the left half and factor out a GCF, which is in this case 4x squared. And what remains is going to be an x plus 2 minus, and then I don't really see a number I can divide out of x and negative 2, so I'm just going to, by default, factor out a 1. You can always do that. And what remains is an x plus 2 again. And then both of these terms have a common factor of x plus 2, so I factor out the x plus 2. And then what remains is the 4x squared minus 1. So that's, we're almost done. Again, if you go back and look at your type 4, we're at this stage right here, and we actually need to factor one more time this piece here using a factoring a difference of 2 squares, and that type is outlined here in type 1. Okay, so we have that happening as well. This x plus 2, I'm going to repeat, just rewrite it. And then the 4x squared minus 1 is a difference of 2 perfect squares, and so it's going to factor, and we memorize the pattern here. 4x squared is 2x times 2x. 1 is 1 times 1, and one of these will have a plus sign between them, one will have a minus sign between them. That's the pattern that we use for factoring a difference of 2 squares. So now we have 3 factors, so we're going to get 3 different answers, and they come from 3 different equations. So x plus 2 is 0, 2x plus 1 equals 0, and 2x minus 1 equals 0. The first one's going to give us x equals negative 2. The second one's going to give us, let's see, 2x is negative 1, so x is negative 1 over 2. And then the third one, we get 2x is equal to 1, so x is equal to positive 1/2. Next one I want to look at is number 11. We have an isosceles trapezoid, ABCD, with AB parallel to DC. So I'm going to draw symbols for AB being parallel to DC, and because it's an isosceles trapezoid, I know that by definition the legs will be congruent. So AD will be congruent to BC. Solve for x if the measure of angle A So that angle right there is given to us, is something, and the measure of angle B is something else. And so we need to know a relationship between angle A and angle B. Now, with trapezoids, there are two different angle relationships that we need to be aware of, and I'll show you them. First of all, in the definition of a trapezoid, okay, you have that angle A, right here, these two angles are going to be supplementary. They add up to 180. And also, these two angles, B and C, are going to be add up to 180. And those are what we call same side interior angles. They are on opposite sides of the, one is connected to one of the parallel sides, one's connected on the other parallel side. What it does not say is that angle A and angle B add up to 180, or angle D and angle C add up to 180. So let's just check if this applies to us. Here it doesn't, because notice angle A and angle B are on the same segment. It's not, you don't have one angle on one and one on the other parallel. So they're not same side interior kind of angles. So that does not apply, but it's something that we'd want to look out for. So if they gave us angle A and angle D, for example, then I'd be able to use that property. Or if they gave me angle B and angle C, I'd be able to use that property. But that doesn't hold here. And then there's one other, and it's something that comes with the isosceles trapezoid. Isosceles trapezoid goes with C number 5 and number 8. So if I go down to number 5 and number 8, 8's what I want. And 8 says that base angles are congruent. And the bases are the sides that are parallel. And in fact, we have angle A and we have angle B, right? And those are going to be the angles that are congruent. So that is what I'm going to use here. The property is that the base angles are congruent. So we can say that the measure of angle A is equal to the measure of angle B. And the measure of angle A is 12x plus 8. The measure of angle B is 3x to the third plus 2x squared. So I finally got to my equation. You want to take your time, make sure it's a good equation to start with. If you thought they added up to 180 and set that up wrong, you would end up with the wrong answer. So you want to be careful that you know how to set these up. So on the first step, make one side equal to 0. This time I'm going to make the left side equal to 0 because I have my positive 3x cubed. My highest power term is on the right side, and it's already starting with a positive, so I'm going to leave that there. And I'm going to make my left side equal to 0 by subtracting 12x and subtracting 8 from both sides. And I get 0 is equal to 3x to the third plus 2x squared minus 12x minus 8. I have 4 terms, so I'm going to be factoring by grouping, which is again is found in type 4 here. And so 0 is going to equal, I'm going to factor out a x squared, and I'm left with 3x plus 2 minus, I'm going to factor out a 4, I'm left with 3x plus 2 again. And then out of these, both these terms have a common factor of 3x plus 2, so 0 is going to equal 3x plus 2 times x squared minus 4. And then the x squared minus 4 is a difference of two perfect squares. So I factor it further using the difference of two squares pattern. X squared is x times x. 4 is 2 times 2. One of these is going to have a plus sign between, one's going to have a minus sign between. I have three factors, so I get three equations and three answers. So set each factor equal to 0 and solve. So the first equation is going to give me x equals negative 2 divided by 3. Second equation gives me x is equal to negative 2. Third equation, x equals positive 2. So those are the three answers for x that apply to this problem. Number 13, we have another isosceles trapezoid where AB is parallel to DC, so AB is one of the bases, DC is the other base, which means our two legs are congruent, right? And solve for x if AC and BD are given. AC, notice that AC is one of the diagonals and BD is the other diagonal. And so makes me curious, is there a property that deals with diagonals with isosceles trapezoids? Let's go look. So the isosceles trapezoid right here has properties 5 and 8, and if I look at property 5, it's about the diagonals, which says that the diagonals are congruent. So that's a property of our isosceles trapezoid, and that's what we're going to use. So diagonals are congruent. Remember, that's also a property of rectangles. Rectangles and isosceles trapezoids are the only two shapes that have that property, that diagonals are congruent, out of the shapes that we're studying. Okay, so I can say that AC is the distance from A to C is equal to the distance from B to D. So x to the third plus x squared plus 7 equals x squared plus 8. And I'm going to set the right side equal to 0 by subtracting x squared and 8 from both sides of the equation. And what I end up with is x to the third minus 1 is equal to 0. Then I need to choose the appropriate type of factoring. I have two terms, and there's three types of factoring that apply to two terms. It could be GCF factoring, so I check that one first, and that one's not going to work here because there's no GCF that I can factor out other than one. Difference of perfect squares. Well, there is a difference here. 1's a perfect square, but x cubed is not a perfect square. Remember, the exponent has to be even for it to be a perfect square, and it's an odd, so it's not. And then perfect cubes is what I look out for. X cubed is a perfect cubed. 1 is also a perfect cube. So this is going to be like type 2. Right? And remember, the pattern here is when we break it up to two terms times three terms, we use the SOAP to help us with the signs, all that kind of stuff. That's what's going to happen in this problem. So it's the factoring using cubes. And so I take the cube root of x cubed, which is x. I take the cube root of 1, which is 1, and that's how I get my first two terms. And then for the 3-term factor, I take the x times itself, and I get x squared. And then x times the 1, which is x, and then 1 times the 1, which is 1. And then I think of SOAP, same sign, which is minus, opposite sign, which is plus, and always positive. And don't forget to put equals 0. And when we have this type of factoring, the trinomial itself that I'm boxing in, this part, will never be able to factor, and it won't give you, right now we don't have to solve that. There will be a way to solve that using a different method that we haven't learned, but up to this point, just know if you're factoring a difference or a sum of cubes, if you're doing the cube factor, the trinomial part you'll just leave alone, and you take the binomial part, the 2-term part, x minus 1, set that equal to 0, and you just get one answer. And that's only true for the cubes. And all that's outlined for you, and kind of I explain that here, right? And you could see that I say here the trinomial is not factorable, and you don't need to solve it at this time. Okay. Lastly, I want to look at number 15. 15, we're given a kite with AB congruent to AD, and we're asked to set up an equation or look for the relationship between DC and BC. So probably thinking they might be congruent to each other, right? But we got to come up with a reason why. And it really comes from the definition of a kite. So if you know the definition of the kite says that you have two adjacent sides that are congruent to each other. So DC and BC would be the other adjacent pair. And it also says that opposite sides are not congruent. So AB and DC can't set equal to each other. So that's different than a parallelogram. With parallelograms, remember the opposite sides are congruent. With a kite, you do not have that. So here, let's write what we have. The definition of a kite is what we're using. Sorry. We have two pairs of adjacent sides congruent. And so DC, the length, is going to equal the length BC. So x to the third plus 3x squared plus 2x plus 20 is going to equal 3x squared plus 2x plus 12. And I'm trying to decide which side should I make equal to 0. And I notice the left side is the only side that has x cubed, which is my highest power. And so that's going to stay put, and I'm going to get rid of the right side, make it equal to 0 by subtracting it out. And I end up with x to the third power plus 8 is equal to 0. So it cleans up real well. And I'm noticing that these are also perfect cubes. And so just like we did 13, we're going to do 15, and it's going to factor to a binomial times a trinomial. And the binomial is going to be x plus 2, because it's coming from the cube root of x cubed is the x, and the cube root of 8 is 2, and it's the same sign. And then x times x goes here. 2 times x is the middle, and 2 times 2 is 4. Use the opposite sign here and make this one always positive. And the 3-term factor is not going to solve, so you don't have to go any further, but I do want to see that you can factor it. So I need to see both factors here when you're doing this. Don't just say, oh, I just need the first one because the first one is what gives me the answer. Give me the full factorization, and then just use the 2-term factor to get your answer. Alright, well that's it for the odd problems on this homework.